We made the design and the construction of the antenna easy. And we're giving an overview on the options over a wide frequency range. We are pleased about the great interest in this antenna type. Meantime, there are a number of references for Wi-Fi, amateur radio, LoRa, and even as a feeder of a 1420 MHz amateur radio telescope. I would like to take this opportunity to say thank you to all the viewers who gave so much valuable feedback and initiated interesting discussions. Today there is even an additional useful tool for everyone to take home. Thanks to Al, we can share a really useful OpenSCAD script that I would like to introduce in this video. But first I'm giving an overview, since we gradually expanded our Excel tool to a number of different designs. Version 4.2 contains all options, made from wire or tube, from conductive foil, as a printed circuit or on substrate, milled from solid metal, as well as made from strip metal. Here's a tip for all electronics fans. If you're thinking about implementing your electronics on a professional PCB, definitely do it, because it's worth it. And be sure to check out PCB's website. The company offers an impressive range of manufacturing services. You could get even our antennas manufactured. All you need to do is upload your design files and you will receive your quote immediately. Take the easy way with PCBWay. And there is a bit of brain power in it now. Our Excel tool has become quite comprehensive. You can use it to dimension all designs of our lambda loop antenna. In case you're interested, you will find a number of videos on the channel on that topic. We have covered practically everything: the working principle, simulation, design examples, assembly and measurement. Meantime, wire design references are comprising 435 MHz, 866 MHz, 1420 MHz and 2.4 GHz. At higher frequencies, the diameter eventually becomes too small for soldering the antenna. However, a diameter of 15 mm is still feasible, which corresponds to a frequency of 6 GHz. For 145 or even 70 MHz, corresponding to a diameter of 66 or 136 cm, a skilled craftsman could build it from tubing. The construction and tuning of the wire design requires some skills, so we started thinking about easy, reproducible designs. Planar designs turned out to be a good solution for that. You can cut a planar antenna from a conductive foil using a paper template. It is even better to 3D print a carrier and simply glue the conductive foil on. We tried both methods for 866 MHz. You will find videos about it on this channel. A 3D printed carrier is suitable for 400 MHz up to about 1.6 GHz, depending on the accuracy and size of your printer. Using a big wooden carrier, the planar antenna could cover the range down to 50 MHz. The printed circuit design is certainly interesting for mass production. Please note, the dimensions differ from the simple planar antenna, as the permittivity of the substrate must be taken into account. It has particularly strong influence on the impedance matching network. I think the design is feasible for the frequency range from 400 MHz to 10 GHz, with a high quality substrate certainly much higher. Using this principle, you can also build a foil antenna for lower frequencies sticked onto a pane of glass, for example. Experiments in the 2 meter band are on our agenda. In my mind, the most stylish design could be achieved by milling the antenna from aluminum or another good conductor. An alternative would be printing the body with PLA material and covering it with a conductive foil. We know that high-frequency currents only flow in a thin outer layer of the conductor anyway, due to the skin effect. Actually, there is no size limit of this design, however, it is getting expensive at low frequencies. Makers know it. Flat material is inexpensive and easy to assemble, so this design is particularly suitable for DIY. Originally, for this design we thought about large antennas down to 50 MHz. However, as you can see, it works very well for 2.4 GHz too. In a nutshell, the frequency-dependent antenna diameter is determining our realization options finally. A good fraction of this frequency range we can cover either as 3D print or as milled part. In that case, we are using the data from our Excel tool as input for a CAD program. I must admit, this is a certain effort in case you are not an experienced CAD user. However, instead of the CAD program, there is now a much easier solution. We are really happy to have viewers with great ideas on electronics unmasked. Al provided us with a great script tool, which we can even share here on the channel. OpenSCAD is a pretty simple tool that runs on your PC without any major installation procedure. We link the website below. The script is literally doing the design work for you. Kudos to Al. You're just entering the calculated parameters, then OpenSCAD creates the three-dimensional body, which you can export as an STL file. We are offering Al's script as well as the Excel tool for download. You can find the GitHub link under the video. I gave my assessment based on practical and economic considerations. There are no hard limits for the frequency range actually. The OpenSCAD script is a really clever trick to avoid the design effort using a CAD program. Perhaps we will create a library containing antenna dimensions and ready-made STL files covering common frequency ranges. What do you think about that? Just comment me on that. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.